First BSc Chemistry, topic Photochemistry, Session 17. The contents are Beer-Lambert's law, numerical problems on absorption coefficient and molar extinction coefficient. Learning objectives to know the colorimetric estimation using Beer-Lambert's law, to know how to solve the problems in photochemistry. Session outcome: to solve the problems in photochemistry. Prerequisites: absorption of light, different wavelengths. So as you know, absorption of light is all types of electromagnetic radiation and different wavelengths you should know, then only we can understand the topic. Now, Beer-Lambert's law. Beer-Lambert's law states that the rate of decrease in intensity of radiation with thickness of absorbing solution is proportional to intensity of radiation and the concentration of the solution. That is minus dIT over dL proportional to IT dot C. C is the concentration, intensity of light, and minus dIT over dL is equal to epsilon into IT dot C, where epsilon is the molar absorption coefficient. By substituting this value here, minus dIT over IT is equal to epsilon into C into dL. If C is equal to 1, then dL is equal to 1, then epsilon is equal to minus dIT over IT. Thus, the molar absorption coefficient is the fraction of light absorbed when it passes through unit distance in 1 molar solution. Application of Beer-Lambert's law in colorimetric estimation. It is very much used in a colorimetric estimation. Calorie means color, metric means measurement, depending upon the concentration of the solution. It is used in laboratories and hospitals to estimate biochemical samples such as urine, cerebrospinal fluid, plasma, serum, etc. It is used in the manufacturing of paints. It is used in textile and food industry. It is used in the quantitative analysis of proteins, glucose, and other biochemical compounds. It is used to test water quality, and it is used to determine the concentration of hemoglobin in the blood. All these applications are used by knowing the colorimetric estimation or colorimetric method by using Beer-Lambert's law. Now let us see some problems, especially the problems on absorption of coefficient and molar extinction coefficient. First one, the intensity of light of 260 nanometer when passed through 1 into 10 to the power minus 3 meter path length of a cell containing 0.05 mole per dm cube solution, and it is reduced to 15% of its initial value. Calculate the optical density and molar extinction coefficient. For that, the solution is log IT over I naught is equal to minus epsilon dash Ci. C is the concentration. It is given 5 into 10 to the power minus 2 mole per dm cube. Now, log IT is 0.15 is equal to IT by I naught. When you calculate, this is equal to 0.15, which is equal to minus epsilon dash into C is 5 into 10 to the power minus 2 into I is 1 into 10 to the power minus 3, the intensity of light. Epsilon dash is equal to 1.648 into 10 to the power 4 per mole per dm cube per meter. The optical density will be epsilon dash into C into 1. Now you have the value of epsilon dash into C you have, I you have. Substituting all these values, you will get optical density is equal to 0.824. Now the second problem is a monochromatic radiation has its intensity reduced to I by A naught is equal to 60% of its initial value as it passes through 1 centimeter thickness of an absorbing medium. Calculate the absorption coefficient and extinction coefficient. Two parameters you have to find out. Solution: I by I naught is equal to 60%, reduced to 60%, that is 0.6. Thickness of the medium will be 1 centimeter, x. Then I by I naught is equal to 10 to the power minus ax is the formula. I by I naught value you know, 0.6 is equal to 10 to the power minus a into x is equal to 1. Here you have to find out what is called as a. That is minus a is equal to log 0.6 gives rise to minus a is equal to log of 0.6 will be minus 0.222. Extinction coefficient is a, that is equal to 0.222. Absorption coefficient is k. K is equal to a into 2.303. This is equal to substituting the value of a, that multiplied by 2.303, you will get 0.511. The third problem. The intensity of monochromatic radiation incident on a solution of 0.02 molar concentration of an absorbing substance which is reduced to 1 by 5 of its initial value after passing through 6 centimeter length of the solution. Calculate the molar extinction coefficient and molar absorption coefficient of the absorbing substance. Now, the reduced mass will be 1 over 5, which is equal to 0.2. Length of the solution is x, that is equal to 6 centimeter. Concentration of the solution is 0.02 molar. Now, substitute the values here. I over I naught is equal to 10 to the power minus a dash cx. The I by I naught will be 0.2 is equal to 10 to the power minus a dash into concentration they have given 0.02 into x is 6. Now you will have the value log, by taking the logarithm, log 0.2 is equal to minus a dash into 0.12 or a dash is equal to minus 5.825. The molar extinction coefficient is 5.825. Molar absorption coefficient is k dash. K dash is equal to a dash into 2.303. Substitute the value of a, then a into 2.303 is equal to a dash into 2.303 is equal to 13.414. Now recapitulation, you have come across Beer-Lambert's law, what is the last states and what is the value or numerical problems you worked out on absorption coefficient and molar extinction coefficient. Thank you.